Engineering design, management of change, establishing a structured, accountable framework for modifications in complex industrial systems. Management of change procedure, a structured workflow for safe, disciplined, and auditable implementation of engineering modifications. The management of change, MOC, procedure is the operational engine that transforms modification proposals into controlled, approved, and executed changes within complex industrial environments. It defines the step-by-step sequence for initiating, evaluating, approving, implementing, and closing out any engineering, configuration, or maintenance modification, regardless of size or scope. This procedure ensures that no change enters the field unless it has been thoroughly assessed for its technical impact, safety implications, and documentation requirements. Each step is designed to promote cross-functional coordination, preserve traceability, and maintain alignment with safety, integrity, and operational priorities. Key stages of the MOC procedure include initiation and problem definition. The process begins when the initiator identifies a need for modification and prepares an MOC proposal outlining the issue, justification, and suggested solution, discusses the proposal with their line manager and obtains preliminary endorsement, engages with the Senior Technical Authority, STA, to classify the modification, engineering, configuration, or maintenance, and identify the responsible job officer, RJO, statement of requirements and circulation for review. The RJO works with discipline engineers to develop a full statement of requirements, SOR, which includes technical details, design criteria, interfaces, affected systems, and estimated cost and schedule, identification of potential safety risks, operational impacts, and procedural knock-on effects, circulation of the SOR to all nominated departments and authorities for structured review and comment, resolution of comments, and technical consolidation. As part of the review process, all reviewer comments are documented in the MOC form, with corresponding responses from the RJO or discipline leads. Revisions are made to the SOR as needed to address technical, safety, or operability concerns. Outstanding issues are escalated to the STA for adjudication and final direction. Final engineering definition and approval routing. Once the technical scope is finalized, engineering details, cost estimates, and implementation plans are compiled into the final work package. The complete MOC package is routed for formal approval by all relevant technical authorities, HSE, facility manager, and senior operating authority. The STA gives final clearance and decides whether a formal safety review, e.g. HAZOP QRA, is required. Authorization for site implementation. Upon receiving full approval, the senior operating authority authorizes the modification for physical implementation. The DCC administrator issues the final MOC package to site teams, ensuring all documentation is current and circulated properly. Execution begins in accordance with approved plans with oversight by the RJO and relevant discipline engineers. Documentation updates and commissioning. During and after implementation, the RJO ensures all affected documentation, P&IDs, loop diagrams, operating procedures, asset registers, is updated and as built. Functional and commissioning tests are performed to validate the modification. Safety systems, control logic, and operator interfaces are verified for operational readiness. Post-implementation review and closeout. After a defined operational period, typically 3 months, the STA conducts a review to confirm the modification's effectiveness and that no unforeseen issues have emerged. The RJO coordinates closeout activities, including final documentation archiving and MOC record closure. If deficiencies are identified, the modification may be referred back for adjustment and revalidation. Ongoing tracking and auditability. The entire MOC lifecycle is monitored via a central database managed by the DCC administrator, enabling real-time tracking of status, actions, and approvals, historical retrieval for audits, investigations, and performance reviews, visibility into modification trends and recurring challenges. The MOC procedure is more than a checklist. It is a disciplined framework that ensures technical modifications are not just engineered, but engineered responsibly. By embedding this structure into every change, organizations foster a culture of proactive control, risk awareness, and engineering transparency, key hallmarks of operational excellence in high-risk industries. Engineering design, management of change, Establishing a structured, accountable framework for modifications in complex industrial systems. Configuration change procedure, controlled adjustment of operational parameters and programmable logic within existing systems. The configuration change procedure governs the structured review, approval, and implementation of non-physical modifications to programmable systems, control logic, and equipment settings. Unlike full engineering changes that involve hardware alterations or design modifications, configuration changes focus on updates to system behavior, often through software, set points, or programmable control logic. Despite their often invisible nature, configuration changes can carry significant operational and safety implications. This procedure ensures they are managed with the same rigor and traceability as physical changes, protecting the integrity of critical systems such as emergency shutdown, ESD, fire and gas, process control, and safety instrumented systems. Key stages of the configuration change procedure include initiation and proposal review. A configuration change begins when an initiator identifies a need to modify a system set point, alarm threshold, or trip logic, change operational parameters in a control loop or DCS PLC logic, adjust functional behavior of safety or environmental protection systems. The initiator consults with their line manager and receives preliminary approval to proceed, classification and technical engagement. The initiator meets with the Senior Technical Authority, STA, to confirm that the change qualifies as a configuration change, not a full engineering modification, identify the responsible job officer, RJO, to coordinate the modification, determine which departments and technical authorities must review the change, assess whether a formal safety review, e.g. SIL assessment, is required, preparation of justification and change details. The initiator documents the problem, rationale, and proposed solution on the MOC form, clear identification of the parameters to be changed, technical justification for the new configuration values or logic revision, any simulation results, calculations, or field data supporting the change. Supporting attachments may include updated control narratives, logic diagrams, and cause and effect matrices. Circulation for review and approval. The completed configuration change proposal is routed to all previously nominated reviewers, including instrument, electrical, and process technical authorities, HSE, maintenance, and facility representatives if affected, the Senior Technical Authority who provides final technical sign-off. The review focuses on verifying that the new configuration does not compromise safety, operability, or system performance. Execution and documentation update. Once approved, the RJO coordinates the configuration change with internal engineering or a designated control systems specialist. The change is executed in accordance with site standards for software and programmable logic updates. All related documentation, loop drawings, instrument databases, control system backups, alarm registers is updated accordingly. The change is tested in the field to verify correct implementation and system response, post-implementation validation. After implementation, the RJO ensures that configuration changes have been communicated to operations, maintenance, and control room personnel. The STA conducts a 3-month post-review to assess whether the change achieved the intended results and did not introduce unintended consequences. The MOC record is formally closed upon validation of success and completeness of documentation. Traceability and audit control. All configuration changes are fully documented in the MOC system and MOC database, providing a complete audit trail of justification, approvals, and technical commentary. Assurance that programmable changes are controlled, reversible, and verifiable. Historical reference for future diagnostics, investigations, or system upgrades. This procedure recognizes that even a simple change to a set point or logic string can have system-wide implications. By embedding discipline into software and configuration control, organizations preserve the reliability, predictability, and safety of automation infrastructure, especially in environments where real-time control and protection systems form the backbone of asset integrity. Engineering design, management of change, establishing a structured, accountable framework for modifications in complex industrial systems. Maintenance modification procedure, optimizing reliability and service practices through controlled adjustments to maintenance strategy. The maintenance modification procedure governs controlled changes to maintenance philosophy, frequency, methodology, and planning across critical equipment and systems. Unlike engineering or configuration modifications, maintenance changes do not involve physical alterations to hardware or software. Instead, they refine how existing systems are preserved, inspected, and serviced over time. These adjustments often stem from operational experience, failure trend analysis, OEM recommendations, or internal continuous improvement initiatives. While they may seem routine, maintenance modifications, if uncontrolled, can increase risk exposure or disrupt preventive regimes. This procedure ensures such changes are justified, coordinated, and properly integrated into the asset's maintenance system. Key stages of the maintenance modification procedure include initiation and preliminary evaluation. The process begins when an initiator identifies a need to extend or reduce preventive maintenance intervals, modify the scope or methodology of routine servicing, e.g., changing inspection techniques or reducing component replacement frequency, introduce new maintenance tasks based on updated risk or condition-based insights, remove redundant or ineffective maintenance activities. The initiator discusses the proposal with their line manager and obtains approval to proceed. Classification and stakeholder engagement. The initiator consults with the Senior Technical Authority, STA, to confirm the change qualifies as a maintenance modification, identify the responsible job officer, RJO, who will coordinate the modification process, determine which technical authorities and support teams, maintenance, process, HSE, etc., should review the change, assess whether the modification warrants further risk review or operational validation. Documentation of justification and proposed adjustment. The initiator prepares the MOC form with a clear summary of the current maintenance strategy and the proposed revision, justification based on operational feedback, failure data, benchmarking, or OEM advisories, expected reliability impact, resource savings, or equipment performance improvements, supporting evidence such as maintenance logs, condition monitoring data, or RCA findings is attached to strengthen the case. Circulation for technical review and approval. The MOC proposal is reviewed by the relevant stakeholders, including maintenance authority, who validates methodology, spares availability, and system alignment, process and instrument electrical authorities, where maintenance changes affect production or control systems, HSE authority, where safety-critical equipment or regulatory compliance is involved. The STA provides final sign-off before implementation, integration into maintenance management system. Upon approval, the responsible job officer ensures the change is integrated into the computerized maintenance management system, CMMS, with updated intervals, procedures, and task lists, reflected in revised job plans, maintenance instructions, and reliability databases, communicated to planners, technicians, and reliability engineers to ensure consistent execution, field implementation, and monitoring. The new maintenance regime is deployed with technician awareness, supervision, and documentation updates, initial performance monitoring to assess whether expected benefits are realized, adjustment of spares inventory or tooling if needed, post-implementation review and closure. After a suitable operating period, typically 3 months, the STA and RJO evaluate the effectiveness of the revised maintenance strategy, confirm that the change has improved reliability or efficiency without introducing new risks, officially close out the MOC, ensuring all documentation is complete and archived, traceability and reliability feedback loop. All maintenance modifications are logged and traceable in the MOC database for future audits and engineering reference, included in lessons learned sessions and reliability reviews, used to inform updates to maintenance standards, criticality rankings, and risk-based maintenance frameworks. This procedure embeds discipline into an area often overlooked: maintenance evolution. By ensuring that maintenance modifications are rigorously reviewed and properly controlled, organizations preserve the balance between operational efficiency and asset protection. In doing so, they turn experience into structured improvement, ensuring every change to how assets are cared for is deliberate, justified, and fully aligned with long-term reliability goals. Engineering design, management of change, establishing a structured, accountable framework for modifications in complex industrial systems. Modification register and update of records, ensuring traceability, version control, and audit-ready documentation throughout the lifecycle of change. The modification register and update of records is the documentation backbone of the management of change, a process. It ensures that every proposed, approved, and executed modification is systematically logged, version controlled, and supported by up-to-date engineering, operational, and maintenance records. Without this layer of administrative discipline, even well-engineered changes can become sources of confusion, safety risks, or regulatory noncompliance. This framework protects the integrity of the engineering baseline, preserves operational clarity, and provides a robust audit trail for internal assurance and external regulatory review. Key components of the register and record management process include centralized modification register, maintained by the Document Control Coordinator, DCC Administrator. The modification register is a centralized digital or physical system that captures all key attributes of every modification. At a minimum, it includes unique MOC number assigned upon initiation, type of modification, engineering, configuration, maintenance, modification title and brief description, responsible job officer, RJO, and associated team, origination date, status updates, and closeout date, facility or system area affected, priority rating or classification of risk impact. This register acts as the authoritative source for tracking all active, pending, and historical modifications within the asset or organization. Dynamic status monitoring and reporting. The register enables real-time oversight by highlighting modifications that are delayed, stagnant, or pending key approvals, supporting weekly or monthly MOC progress reports to project and operations leadership, flagging overdue documentation updates, temporary modification expiry, or incomplete closeout actions. Document updates, triggered by approved changes. Once a modification is approved and implemented, the RJO ensures that all affected technical and operational documents are updated. These may include piping and instrumentation diagrams, PNIDs, process flow diagrams, PFDs, and equipment data sheets, instrument loop drawings, electrical single-line diagrams, and software backups, safety case documents, cause and effect charts, and hazardous area classifications, operating procedures, maintenance routines, and equipment registers. Controlled document revision and as-builting, updated documents are revised under formal document control protocols with revision history maintained, reviewed and validated by relevant technical authorities before release, stored in a centralized document management system, DMS, for easy retrieval and compliance, cross-linking with supporting systems. The modification register interfaces with maintenance management systems, e.g. CMMS to align asset hierarchy and preventive maintenance regimes, engineering document management systems for tag databases, data sheets, and model references, safety and risk management systems for alignment with risk registers, SIL assessments, and incident investigations, closeout certification, and archival. Upon successful implementation and validation of a modification, the MOC record is formally closed by the RJO with confirmation from the Senior Technical Authority. All supporting documentation, including approvals, comments, and test results, is archived. The modification register is updated to reflect final status and closeout date, preserving long-term traceability. By maintaining a robust and well-governed modification register, organizations not only track the evolution of their facilities, they demonstrate due diligence, enable safe operations, and reinforce confidence among auditors, regulators, and stakeholders. This structured approach ensures that change is not just approved and executed, but also permanently recorded, easily retrievable, and fully integrated into the fabric of engineering and operational knowledge.